So our first animal is our koi fish. They're our vertebrate group identified using Seek. These koi fish were found at the Penn State Arboretum in a pond in the back corner. They are, for the most part, domesticated animals. They tend to live in ponds and personal lakes or gardens, as they're found here in a little pond in a garden. They usually all swim together. You'll never just see one on their own. They all are always pretty much in a group or school. They have a meaning behind them as to why uh, the Japanese culture, the Japanese believe the fish hold value, and it's value for things like good luck and fortune. And yeah. And these fish are very smart. They're a lot smarter than a bunch of other sea animals, water living animals. An example would be they can remember who feeds them. So you can feed them for a week and all of a sudden they see your face and they think, oh, it's time to get fed. For the invertebrates, we are using a sea anemone identified using Seek. This one in particular was found at the hub in a fish tank located on the ground floor. These sea anemones are really important to the environment. They provide clownfish with shelter and even defense. On the tip of every single little tentacle you see floating around, there is a small jagged edge needle, and that inside those contains toxic venom to stop predators from eating them or the clownfish that live in them. It was mentioned in the Media Line article that these creatures could be used for future drug research. I think that's pretty cool. They still have a lot to do, and it's still really new, so there's not too much information, but these creatures will one day hopefully be used to find vaccines or some other form of potential good drugs. And then last thing about these is they don't have any bones. They have a hydrostatic skeleton, which is where they use fluid to create their structure. So there's no actual bone or anything like that inside of a sea anemone. It's all liquid water, pretty much. And then for a fungus, we had lichen, identified using Seek. Lichen is pretty much only found on trees or living organisms. It lives on the side of them, and it actually collects sunlight for its growth. And it's really good for the environment because it can detect the air quality in a certain area. It loves carbon dioxide and oxygen. It does not like sulfur dioxide or any sort of nitrogen fused air. So therefore, whenever you see it, it means the air quality around it has to be good. Otherwise, it wouldn't be here. They live on trees. They don't harm the trees in any way, but they do help convert carbon dioxide into oxygen for us. Yeah.
Northern Carnadale. I found this bird in my backyard at Attic City, Maryland. The northern Carnadale is a striking bird known for male, very red feather and distinct chest. Native to North America, they only common found in woodlands, gardens, and urban areas. Carnadales are significant in many cultures, often symbolize hope, vitality, and a message from loved ones. They are extremely intelligent and quick learners, frequently returning to familiar feeding spot. Lemongrass. I found this lemongrass at the Penn State student farm. I was surprised by its smells. When I first learned it smells like lemon Lemongrass is a tropical plant known for its strong curtis, scent, and flavor. It thrives in warm climate and is often found in gardens and farms. Widely used in cooking, especially in Asian cuisine, lemongrass also had a medical purpose and is popular in teas and essential oils. The plant grows in tall, slender stalks and is easy to cultivate, making it a common choice for sustainable farm practice. So my research question is, how does soil pH affect the growth rate of lemongrass? My hypothesis is lemongrass will grow more vigorously in slightly acidic to neutral soil compared to more alkaline or high acid soils. This hypothesis is based on the general understanding that many plants, including grasses, tend to thrive in slightly acidic to neutral conditions. But lemongrass may have a narrow pH tolerance given its tropical origins. Impact on nutrient uptake. Most grass thrive in a soil pH range of 6.0 to 6.5. Within this range, essential nutrients like nitrogen, phosphorus, and potassium are more readily available for absorption. Acid soils. In more acid conditions, the availability of nutrients like phosphorus decrease. Additionally, toxic metals such as aluminum and magnesium become more soluble, which can inhibit root growth and the function. Alkaline soil. In alkaline soil, micronutrients like iron, zinc, and magnesium become less available, potentially leading to deficiency that affect plant health. Effects on plant growth. Plant height and biomass. Studies have shown that grasses growing in optimal pH conditions exhibit increasing plant height and biomass due to measured nutrition uptake. Proper pH level encourage robust root system, enhance the plant's ability to access water and nutrients. Soil pH influences the microbial population in the soil, which plays a role in organic matter decomposition and the nutrient cycling. Tropical plants often require special pH range to maximize growth. For instance, certain tropical grass and crops have demonstrated the optimal growth in slightly acid soils. Adjusting soil pH in tropical region can lead to significant improvement in crop yields and overall plant health. So we had two management practices in this experiment. The soil testing, regular soil pH testing help in making informed decisions about soil adjustment, and the pH adjustment. Applying lime can raise soil pH, while sulfur containing compounds can lower it, helping to achieve the desired pH balance. So our conclusion is maintaining the optimal soil pH is essential for maximizing plant growth and health. By ensuring that the soil pH is within the ideal range for special plant species, gardeners and agricultural professionals can enhance nutrient availability, promote vigorous growth, and improve crop yields.